added advanced reasoning capabilities to Grok, and we've been testing them pretty heavily over the last few weeks. I wanted to give you a little bit of a taste of what it looks like when Grok is solving hard reasoning problems. So we prepared two little problems for you. One comes from physics, and one is actually a game that Grok.
It's clear that when Elon Musk referred to Grok 3 as the world's smartest AI, he wasn't just joining the hype. Today, he officially introduced Grok 3, and it stands out as the most intelligent AI, excelling across various benchmarks. In this video, I'll walk you through all the key announcements surrounding Grok 3, and I'll explain why this is currently the most advanced AI in existence. One of the first things people are naturally curious about is the benchmarks. Looking at Grok 3, the non-reasoning model, we can see that its benchmarks are truly impressive across the board. It's clear that both Grok 3 and Grok 3 Mini have surpassed recent leading models such as Gemini 2, DeepSeek V3, Claude 3.5, Sonnet, and even the recently updated GPT-4. This is an extraordinary achievement, even if you think benchmarks are just numbers. The team goes on to explain why they explored new benchmarks and tested Grok 3 against them, still managing to outperform expectations. It looks like all the extensive training has made the model significantly smarter, and the scaling laws are continuing to show outstanding results.
The model is still currently training, actually. So this is a little preview of our benchmark numbers. So we evaluated Grok 3 on 3 different categories: on general mathematical reasonings, on general knowledge about STEM and science, and then also on computer science, coding. So AIME, American Invitational Math Examination, hosted once a year. And if we evaluate the model performance, we can see that the Grok 3 across the board is in a league of its own. Even its little brother, Grok 3 Mini, is reaching the frontier across all the other competitors. So you would say, well, at this point, all these benchmarks, you're just evaluating the memorization of the textbooks, memorization of the GitHub repos. How about the real-time usefulness? How about we actually use those models in our product?
Another thing I really admire about the Grok 3 team is how they've taken their model into the chatbot arena. If you're not familiar with the chatbot arena, it's not your typical standardized test. Instead, it's a challenge where 2 AI models respond to the same question, and you have to choose which response you think is better. The test is blind, meaning you don't know which model gave which response. You just select the one you prefer. Over time, they track which model has the most wins. Currently, Grok 3 is leading in the chatbot arena, showing that even in blind tests, where there's no bias towards model names, it's the clear winner. And keep in mind, this is just the non-reasoning model.
We actually kicked off a blind test of our Grok 3 model, codenamed Chocolate. It's pretty hot.
Yeah, hot chocolate.
Been running on this platform called Chatbot Arena for 2 weeks. I think the entire X platform at some point speculated this might be the next generation of AI coming our way. So how this Chatbot Arena works is that it strips away the entire product surface, right? It's just raw comparison of the engine of those AGIs, the language models themselves, and place an interface where the user will submit one single query, and you get to show 2 responses. You don't know which model they come from, and in the end, you make the vote. So in this blind test, Grok 3, an early version of Grok 3, already reached like 1,400. No other models has reached an ELO score, head-to-head comparison to all the other models at this score. And it's not just one single category. It's 1,400 aggregated across all the categories in chatbot capabilities, instruction following, coding. So it's #1 across the board in this blind test.
And it's still climbing, so we actually have to keep updating it. So it's 1,400, above 1,400 and climbing.
Yeah, and in fact, we have a version of the model that we think is already much better than the one that we tested here.
Yeah.
We'll see, how far it gets, but that's the one that we're, working on, or talking about today.
Yeah. So actually, one thing, if you're using Grok 3, I think you may notice improvements almost every day, because we're continuously improving the model. So literally, even within 24 hours, you'll see improvements.
Now, let's dive into the exciting part. The reasoning model. These models are designed to think for an extended period rather than providing an instant response. If you're wondering why this is important, it's because it allows the models to take more time, leading to better, more thoughtful responses. This results in increased accuracy and the ability to solve more complex problems. As an industry, we've been moving in this direction because it shows promising results and is likely to be the key to achieving truly intelligent AI. When we examine Grok 3's reasoning capabilities, it's clear that it outperforms even the recently introduced O3 Mini, which many had considered the smartest AI on the planet. Unfortunately for O3 Mini, it's now been surpassed and is currently in second place.
Okay, so let's see how Grok does on those interesting, challenging benchmarks. So reasoning, again, refers to those models that actually thinks for quite a long time before it tries to solve a problem. So in this case, around a month ago, the Grok 3 pre-training finished. So after that, we worked very hard to put the reasoning capability into the current Grok 3 model. But again, this is very early days, so the model is still currently in training. So right now, what we're going to show to people is this beta version of the Grok 3 reasoning model. Alongside, we also are training a mini version of the reasoning model. So essentially, on this plot, you can see the Grok 3 reasoning beta and then Grok 3 mini reasoning. The Grok 3 mini reasoning is actually a model that we train for much longer time. And you can see that sometimes it actually performs slightly better compared to the Grok 3 reasoning. This also just means that there's a huge potential for the Grok 3 reasoning because it's trained for much less time. All right, so let's actually look at how it does on those three benchmarks. So Jimmy also introduced already. So essentially, we're looking at three different areas: mathematics, science, and coding. And for math, we're picking this high school competition math problem. For science, we actually pick those PhD level science questions. And for coding, it's also actually pretty challenging. It's competitive coding and also some lead code, which is some code interview problems that people usually get when they interview for companies. So on those benchmarks, you can see that the Grok 3 actually performed quite well across the board compared to other competitors. So it's pretty promising. These models are very smart.
Yeah. So Tony, what are those shaded bars?
Yeah, so I'm glad you asked this question. So for those models, because it can reason, it can think, you can also ask them to even think longer. You can spend more what we call test and compute, which means you can spend more time to reason, to think about a problem before you spit out the answer. So in this case, the shaded bar here means that we just ask the model to spend more time. It can solve the same problem many times before it tries to conclude what is the right solution. And once you give this compute or this kind of budget to the model, it turns out the model can even perform better. So this is essentially the shaded bar in those plots.
Mm-hmm. Right. So I think this is really exciting, right? Because now, instead of just doing one chain of thoughts with AI, why not do multiple all at once?
Yes.
So that's a very powerful technique that allows us to continue to scale the model capabilities after training.
The team also wanted to investigate whether the impressive results were simply due to the extensive training and massive dataset, or if it was just overfitting, essentially memorizing parts of the test. To test this, they decided to try it on the new AM 2025, and the results were quite surprising.
And people often ask, are we actually just overfitting to the benchmarks?
Yes.
So how about generalization?
So yes, I think, this is definitely a question that we are asking ourselves, whether we are overfitting to those current benchmarks. Luckily, we have a real test. So about 5 days ago, AMY 2025 just finished. This is where high school students compete in this particular benchmark. So we got this very fresh new competition, and then we asked our two models to compete on the same benchmark, the same exam. And it turns out, very interestingly, the Grok 3 reasoning, the big one, actually does better on this particular new fresh exam. This also means that the generalization capability of the big model is stronger, much stronger compared to the smaller model. If you compare to the last year's exam, actually this is the opposite. The smaller model kind of learns the previous exams better. So yeah, so this actually shows some kind of true generalization from the model.
That's right. So 17 months ago, our Grok 0 and Grok 1 barely solved any high school problems.
That's right.
And now we have a kid that just already graduated. The Grok is ready to go to college. Is that right?
Yeah. I mean, it won't be long before it's simply perfect. The human exams won't be hard. They'll be too easy.
Yeah. And internally, we actually, as the Grok continue evolves, we're going to talk about what we're excited about. But very soon, there will be no more benchmark left.
Yeah.
Now, let's take a closer look at these reasoning capabilities in action, so you can see for yourselves what these models are truly capable of.
Yeah, so like Jimmy said, we've added advanced reasoning capabilities to Grok, and we've been testing them pretty heavily over the last few weeks in order to give you a little bit of a taste of what it looks like when Grok is solving hard reasoning problems. So we prepared two little problems for you. One comes from physics, and one is actually a game that Grok is going to write for us. So when it comes to the physics problem, what we want Grok to do is to plot a viable trajectory to do a transfer from Earth to Mars, and then at a later point in time, a transfer back from Mars to Earth. And that requires some physics that Grok will have to understand. So we're going to challenge Grok, come up with a viable trajectory, calculate it, and then plot it for us so we can see it. And yeah, this is totally unscripted, by the way.
That's the entirety of the prompt, which should be clarified, is that there's nothing more than that.
Yeah, exactly. This is the Grok interface, and we've typed in this text that you can see here: generate code for an animated 3D plot of a launch from Earth, landing on Mars, and then back to Earth at the next launch window. And we've now kicked off the query, and you can see Grok is thinking. So part of Grok's advanced reasoning capabilities are these thinking traces that you can see here. You can even go inside and actually read what Grok is thinking as it's going through the problem, as it's trying to solve it.
Yeah, we should we are doing some obscuration of the thinking so that our model doesn't get totally copied instantly. So there's more to the thinking than is displayed. Yeah.
All right, so this was the little physics problem we had. We've collapsed the thoughts here, so they're hidden. And then we see Grok's answer below that. So it explains, it wrote a Python script here using matplotlib, then gives us all of the code. So let's take a quick look at the code. Seems like it's doing reasonable things here, not totally off the mark. Solve Kepler says here, so maybe it's solving Kepler's law numerically. Yeah, there's really only one way to find out if this thing is working. I'd say let's give it a try. Let's run the code. All right, and we can see, Grok is animating two different planets, Earth and Mars here, and then the green ball is the vehicle that's transiting, the spacecraft that's transitioning between Earth and Mars. And you could see the journey from Earth to Mars, and it looks like, indeed, the astronauts returned safely, at the right moment in time. Obviously, this was just generated on the spot, so we can't tell you if that was actually correct solution. So we're going to take a closer look. Maybe we're going to call some colleagues from SpaceX, ask them if this is legit.
It's pretty close. I mean, there's a lot of complexities in the actual orbits that have to be taken into account, but this is pretty close to what it looks like.
Awesome.